Today on 5.3, we are doing so 5.3c, multi-angle, angle equations. And in the multi-angle equations, whereas previously, if we were given an angle theta, and we were given, let's say, theta, and we were given, let's say, sine of theta equals 1/2. Well, then the opposite is 1, my hypotenuse is 2. Well, then the adjacent must be √3. We're dealing with 30, 60, 90. My angle, my theta, is 30 degrees, or in terms of radians, we're going to be working with radians, is that it is pi over 6. Pi over 6. But now, let's say now, we take it to another step. Let's say, what if my sine of x divided by 2 equals 1/2? Well, the x divided by 2 is my theta. It is my angle. But now we just take it another step and we say, okay, x divided by 2, it's theta. What is x? What is x? So within theta, what is x? So what does that mean? So here, same steps, right? The opposite, adjacent, √3. So my sine, my theta here is, but instead of theta, we get x divided by 2. So here, I know x divided by 2 must equal 30 degrees, or in our case, pi over 6. And x then must equal pi over 3. But we also have to be careful because there are more than one answer, because sine is positive in multiple equations, right? In the second equation and in the first equation. And in my first my first and second quadrants. So now we dealt with the first quadrant, which is pi over 6. But x over 2 can also equal, rewrite that, x over 2 can also equal 5 pi over 6. And then in that case, our x can also equal 5 pi over 3. So these are the two answers that our x can equal. Let's do another example here. What if I have cosine of 3x equals 1/2? Well, first things first, my cosine is positive. So my cosine, it could be these two angles right here. And this is my 3x, and this is also 3x. These are my angles, and it's 1/2. That means the adjacent, it's 1. Hypotenuse is 2, so I got a √3 and a negative √3, but those are the two angles that I can have. It's opposite of √3, so I got it's 60 degrees. So my answer is 60 degrees, which is pi over 3, or all the way 60 degrees. It could be 5 pi over 3. Let's see here. 6 pi over 3 is 2 pi. So 5 pi over 3 is the other one. So then I just set them up equal. So I have 3x equals pi over 3. X can equal pi over 9, and 3x equals 5 pi over 3. X can equal 5 pi over 9. So those are the two possible answers that I have. Let's do one last example here. Let's say I have a cosine of 2x minus cosine of x equals 0. Well, I have a 2x and an x, so I want to convert them all into just plain old x, so I'm going to use my trig identity. My trig identity of cosine of 2 theta equals 2 cosine squared of theta minus 1. So that's the trig identity I want to use because I just wanted theta and I just want to keep purely cosine. So here, this becomes 2 cosine squared of theta x minus 1 minus cosine of x. So I'm going to rewrite this just to make my life easier. 2 cosine squared of x minus cosine of x minus 1. And now I'm going to factor. And don't think of this as cosine. Think of this as 2x squared minus x minus 1. If I were to factor this quickly, this would be 2x and x, 1 and 1 minus 1 plus 1. If I factored that quickly, but this time I'm using cosine. So this is 2 cosine of x plus 1 and cosine of x minus 1, and it should factor to make the top. So that means my answer is that my cosine of x equals negative 1/2, and my cosine of x equals 1. Well, let's think about this. When does x equals negative 1/2? Well, we have that in the second and third quadrant. And I'm just going to put this x here, adjacent, so this is negative 1, negative 1. Opposite is root 3, so we got 60 degrees here. So 60 degrees. So one of them can be 60 degrees. 2 pi over 3 is one of them, and the other one is 4 pi over 3. Is what we are working with. And then finally x equals 1 whenever x the angle is 0. So x can equal this, or x can also equal 0. And those would be my answers.